Okay, did you have fun doing these example problems, even if you did them? Well, we're going to do them together at least. So if you didn't do them, you at least get to do them along with me. If you did do them, you get to check your answer and kick back, eat some popcorn, enjoy the show, and laugh at everybody else when they get the problems wrong on the test. So we're going to go through each one of these, and we're going to have to draw the structures of them. So the very first one was M-chlorotoluene. All right, so here is my benzene ring. I better know to start here. If not, you've not been paying attention. So here's the benzene ring, and I'm just going to put the toluene piece up here because it said M-chlorotoluene. So this is O-M, and that's what we need, M, and it's M-chloro. So folks, there you go. Yours could look a little bit different than mine. If it does, that's not a big deal, as long as these two groups are separated by one carbon. That's really all that we're wanting. All right, so for B said P-bromophenol. All right, so P-bromophenol. There's my benzene ring. Phenol means OH group. So the P means O-M-P, Becky. There we go. And that P was a bromo. So there is P-bromophenol. Look how fast we're going through these examples. Lickety split. All right, so here's another benzene ring. And for part C, it says O-nitro aniline. All right, so aniline, I know, is an NH2 group. There we go. And O means right beside of, right? So there's the O position. And what is O to it? A nitro group. And a nitro is NO2. For D, we have M-chlorobenzonitrile. Okay, so here is a benzene ring. The nitrile group is a carbon triple bond N. And meta to that position is a chloro group. So just to kind of play with your head a little bit, I consistently try to do the same thing over and over, right? But here, maybe just because I'm left-handed, maybe because I want to screw with you a little bit, we're going to go left-handed instead, because I can. Ortho, meta. This is a meta position as well, so I can put the chloro to the left-hand side, just like I put the meta-chloro to the right-hand side up here. It doesn't matter. It's still the same compound. Who cares? All right, E. E is another benzene ring. Of course it is. And we have 2-bromo, 4-iodo-phenol. Oh, gosh. Now they're really sucking it to me because this is 3. All right, so phenol, I know that. It's benzene with an OH. Well, at the second carbon, because by default now there's my first carbon, right? There's my first carbon. I named it a phenol. So at the second location, that would be here, right? This is carbon 1. There's carbon 2. I have a bromo group. Carbon 3, and then carbon 4 is there. And off of carbon 4, I have an iodo. And folks, there you go. There's 2-bromo, 4-iodo-phenol. Once again, just to play with you a little bit, if I want it to go the other way and say, I'm rebellious, I'm not going to go right-handed, you could do that. This is spot 1, no matter how we look at it. This would be spot 2 as well. So 2-bromo, there's carbon 3, and that's still carbon 4. So that is also an acceptable answer. It doesn't matter how you go around the ring. That's the beauty of organic yet again. It also makes my life miserable because there's so many different ways that people can draw these structures and end up with the same answer, and I have to check every single one of them. All right, F. We have M-dichlorobenzene. Okay, so here's the benzene ring. M is dichloro. All right, so just to mess with you a little bit more, because I think we're getting to that point where we're feeling a little more comfortable with these, I'm just going to slap my first chlorine right there. Not up at the top. I normally go to the top, and that's how I do it every single time. That's just me. But here, just to prove a point, I'm going to slap my first chlorine on it. There you go. So I need a meta from that spot. Not a big deal. Here's the O, there's the M. O-M, right? So there's the meta, and I'll write a chlorine that's there. If you don't like that, that's okay. Because what we could also do is not put the chlorine there, but put the chlorine on the other side. O-M-P, Becky. There's the M. And that is where I can put my other chloro. That is also acceptable. It's the same thing. So it doesn't matter how you put them on the ring, as long as you find a way that works for you, and as long as you give me a structure that matches that name. That seems kind of silly, doesn't it? But that's the way it goes. So many choices. All right, next one, G. 2,5-dinitro Benzaldehyde. Woo! Woo, doggy. All right. So Benzaldehyde, I'm just going to start up here at the top. That's a C double bond O with an H. There's the aldehyde group. So therefore, this is Benzaldehyde. Now, the next one says 2,5-dinitro. Well, there's my first carbon by default, because that's the Benzaldehyde piece. So at carbon number 2, I have a nitro, NO2. And then at carbon number 5, so this is my second, there's my third, there's my fourth, there's my fifth. So at carbon number 5, I also have a NO2 group. There you go, 2,5-dinitro Benzaldehyde. Now for H, which is our last one, by the way, we have a benzene ring. That benzene ring says 4-bromo, 3-chloroaniline. All right, so I'm just going to do something screwy again. I'm going to put an NH2 down here at the bottom, just to kind of make us feel uncomfortable for a minute. That's good for you. So there's the aniline piece. That aniline piece is spot number 1. Now, I've got to come up with a 3-chloro and a 4-bromo. So just to mess with you more, I'm going to go left-handed. I can do it. So there's carbon 1, carbon 2, there's carbon 3. So at carbon number 3, we have a chloro group. And then at carbon number 4, we have a bromo group. There you go, folks. There's that question answered within a couple of minutes. It looked like we had 8 examples that we had to draw structures of. And even with my jib-jab, we were able to answer that in 5 minutes or so. Can you imagine? Again, we thought this was going to be complicated, but when we go and actually dissect these names, we're going to see that hopefully this is not too bad. I feel pretty good about what's happening right now, right? Okay, so let's take a look at another example. Correct the following incorrect names. Okay, so these problems typically drive people crazy, and the reason is because they don't know how to answer them. So this problem basically is telling me that A, B, C, D, those names are incorrect in some form or fashion. And they want to know what's wrong about them, how do we fix them, and what would be the proper name instead. All right, so I'll show you the way that I answer these questions. I think that it makes it a little bit easier. All right, so we're going to start off with A. And A is going to say 2, 4, 6, Bromobenzene. Okay, well, let's draw this, and let's start there. Okay, so here's my benzene. There we are. There's the ring. 2, 4, 6. All right, so I'm just going to randomly pick one of these carbons as my first one, so I'll pick that as my first. So this would be carbon number 2, bromo. 3, 4, bromo. 5, 6, bromo. We'll start here. So imagine for a minute that I told you, here's a structure, name it. And I give you this structure. How would you name this structure? Without even looking at part A, 2,4,6-tribromobenzene, if I give you the structure only, and I said, name this for me, please, on a test, how would you name it? Well, you would come in and you would probably look at this and say, oh, this is a benzene, so I can at least start there. And you would look at the 3 bromo groups and you would say, hey, this is a tribromobenzene. And you would look at the bromos and you would say, all right, it doesn't really look like they're clustered on one side or the other. So let's say that here's my first bromo. I'm going to probably label this as number 1, number 2, number 3, number 4, and number 5. And you would say this is called a 1,3,5 tribromobenzene. Ding ding, you're correct. Good job for you. Because that's how this name is incorrect. If I look at 2,4,6-tribromobenzene and I draw that structure, I know that that name is wrong because 2,4,6 is not appropriate. It's actually 1,3,5. That's the best way to answer these questions. Now, let's look at another one. For B, correct the following names. 3-hydroxynitrobenzene. All right. So let's try to name this thing. Or draw the structure. Sorry. So we've got 3-hydroxynitrobenzene. All right. So if I had to draw this, here's the structure of my benzene ring. 3-hydroxy. All right, so I'm just going to say this is carbon number 1. So carbon number 2, carbon number 3. That's just the way that I've drawn it on a sheet of paper. And at this location is hydroxy. All right, well, if you go back and take a look at the hydroxy label, this is a sign that it's an OH group. All right, so an OH is going to go here. And then nitro doesn't really have a number associated with it. So it's understood to be 1, which means at that first carbon that I've identified, this is probably an NO2 group. All right, so this is the name that they give me. I've drawn a structure that represents that name. Now, we know that something's wrong. I've got to figure out what it is. Well, once again, pretend like you did not see this name. And go and give me a name of this molecule if I give that to you on an assignment. How would you name that structure? Forget about the name that they gave you. That's only a place for us to start. Because we know it's wrong anyway. So for part B, I would look at this ring and I would go, oh, well, you know, he told me that I should memorize the name of a benzene with an OH group, and that is called a phenol. And that means that this is automatically number 1, and this is group number 2, and this is group number 3. So at spot number 3, I have a nitro group. So the name of this structure, Mr. Holbrook, or Tracy, is 3-nitrophenol. And I would go, correct! Good job! You studied! And that is how the name for B is incorrect. It did not name it as a phenol, which means that that OH group had to get priority because we named it as a phenol. And that also means that nitro is at spot 3 because I'm naming it as a phenol. That's the name that we use for a benzene with an OH group. All right, number C. Maybe these are getting a little bit better. Number C says para-methyl bromobenzene. All right, so let's clear off the screen. They told me para-methyl bromobenzene. So that means in the structure, I have a benzene ring. It's there. I also have a bromo and a methyl that are para to each other. All right, so there they are, para to each other. And I'll just write a CH3 group here for the methyl and the Br for the bromo. And now we step back and we look at this and we say, what's wrong with it? There's something wrong with the name? Well, here's where things get a little fuzzy. In this example problem, they told you something was wrong with the name. Fix it. However, there really isn't anything wrong with this name because IUPAC decided to change the rules and say don't name things with a benzene and a CH3 group as a toluene anymore. So here they go through the effort in the textbook to give me this rule change, and then in an example problem they forget to change the rule change of the example problem. Yet again, professors and graduate students miss it, and they give it to people like you who study this and say, well, wait a minute, I'm confused, I don't know what to do because it looks like this is proper. And it is a proper name. Para, opposite of each other, methyl bromobenzene. But in the olden days of 2 years ago, they basically wanted you to answer the problem this way. They wanted you to look and regard the benzene ring with the CH3 group as the toluene structure. And because of that, that is spot number 1. So at spot number 4, there is a bromo piece. 4-bromotoluene would be the appropriate name just a couple of years ago, and that is why this name is incorrect. However, they changed the rule and they said, you know what, ding ding, that's correct. We would like for you to name the structures this way now. All right, so this was kind of a trick, but it wasn't a trick a few years ago, but it's a trick now because para-methyl bromobenzene is acceptable. There is nothing wrong with that name at this point. All right, now let's go to D. D says 1,6-dichlorobenzene. All right, so once again, we'll start there. 1,6-dichlorobenzene. So let's figure out what this is. All right, so here is my benzene ring. At spot number 1, I have a chloro. So spot number 2, spot number 3, spot number 4, spot number 5, spot number 6. So at spot number 6, I have a chloro group. Okay, that's great. That's the name that they want to provide me, but I know that this name is probably wrong. So how is it wrong? Well, once again, forget about the name at this point. Pretend like they didn't give you anything, and pretend like I gave you this problem, and I wanted you to answer this problem by giving me an acceptable name. How would you do it? Well, you would look at this and say, oh, well, okay, this is a benzene. And this benzene, it looks like they want numbers, so I don't want to do ortho and metas and paras, so let's give them numbers. So this is chlorine number 1. But the next step would go to here, chlorine number 2. This is actually a 1,2-dichlorobenzene, not a 1,6. 1,6 gives me a higher group number. 1,2 is more appropriate. They are side by side. Well, if you didn't want to start with number 1 at the top, no sweat. You could have started number 1 to the left-handed carbon and went number 2 to the one at the top. It still would have been a 1,2-dichlorobenzene. No big deal. No difference in them. All right. So there's the nomenclature lesson of substituted benzenes, disubstituted benzenes, trisubstituted benzenes. And now we are done with nomenclature. So what's next? Well, that means reactions, right? We name, react, name, react, name, react, name, react. And we're getting ready to go into the reactions of these substituted benzenes at this point. They're a little bit different than the first set of reactions that we did with benzene. Remember, there were 5. Go back, take a look at those 5, figure out what they were and what they did, because we're going to be using those yet again in this section. So we're going to revisit benzene reactions, talk about how they're different and why they're different, because this time we're using substituted benzenes in this lecture portion. All right, so this is where we're going to start when you come back in the next video. So be prepared to take some notes, crack those knuckles, go take that break, get those carbohydrate fixes in. Carbohydrates love brain function. That's why people binge on potato chips and sandwiches and pizzas. It actually does you pretty good. All right, so I'll see you in the next video, and we'll talk about reactions.